For step 1, we computed the average and standard deviation of weekly demands in units for each product. We found the sum of demand, the average of demand, and of course, the standard deviation of demand. We figured out the grand totals of each of them by using the sum, the average, and the standard deviation function in Excel to find them. The sum of demand was 43,225. The average of demand was 415.625. And lastly, the standard deviation of demand was 226.880370. Finding these numbers helped us find and address some of the variability in the supply and demand of the products, and of course, finding the product's weekly demand.
In this step, we used each individual product's weight and were able to compute the average weekly demand and the standard deviation of weekly demand based on these weights. We did this by multiplying both of these numbers from the last step with the product weight for each individual product. We will use this information again in the next step when determining transportation costs. In this step, we used the average weekly demand in pounds to calculate total weekly transport costs for each individual product, depending on the transportation method chosen. We then took this number and divided it by the weekly unit demand to find the transportation cost per unit. This data showed us that trucking is the cheapest transportation method, however, it does come with some of the longest lead times. Next, we used the distance from the plant and the average weekly demand in pounds, as well as emissions data, to compute the weekly emissions. We then took these numbers and divided them by weekly unit demand to find the emissions per unit. We found that trucking has the lowest emissions per unit, followed by ocean and then by air shipping.
Step 4, we had multiple calculations that provided us answers for total inventory and the inventory holding cost per unit for each week. We concluded that you will have the most inventory during week 16 for product 2, plant 2, with a total of 10,010 units in inventory. The inventory holding cost per unit for product 4, plant 2, during week 16 is the most expensive. It is $10.75 per unit. Now the cheapest is from product 3, plant 2, during week 3 with only 63 cents. In step 5, we calculated the labor cost per unit by multiplying labor rate and labor hours per unit. We came to the conclusion that labor is going to be the most expensive from product 1, plant 1, with a total of $145 per unit. And labor is going to be the cheapest from product 2, plant 2, with only $8 per unit.
For our solutions, we did the simple calculations that we used from previous calculations and combined them. For example, for profit per unit, we utilized the cost per unit, the total cost per unit, and then the revenue per unit. Then we subtracted each other, and that's what we got. And from there, we used these calculations to calculate the annual profits by taking the profit per unit and multiplying that by the average weekly demand, and then multiplying all of that by 52 for the weeks that's recording the data. We did a very similar process with annual emissions of kg by taking emissions per unit, multiplying that by average weekly demand units as well, and also multiplying that number by 52. Based on the previous calculations that I spoke on the previous slide, we have found 4 recommendations for each product. For product 1, we have decided that the road transportation for plant 1 is a better option, specifically because it is going to be the more cheaper and has lower annual emissions in comparison to the heavy air cargo of plant 1. This is for product 1. And then moving on for product 2, there was 4 different options, and we narrowed it down to the road transportation for plant 1 and or the road transportation or the ocean transportation of plant 2. The reason why there's 2 options is because they both are opposites. The ocean transportation method is the cheaper option, but has a higher annual emissions, but it's also more profitable. On the other hand, the road transportation is more expensive, but it has lower annual emissions. Now, this is up to Chocolate Hawkeyes to decide on whether you guys want to have a more profitable but a higher in emissions transportation method, or have a more expensive option but would have a lower emissions. And then moving on to product 3, the recommendation is of the ocean transportation for plant 2. Similarly to product 1, this is going to be the cheaper and the lower annual emissions option in comparison to the air travel from plant 2 for product 3. Product 4 is exactly the same as product 2. Is going to be the road transportation from plant 1 or ocean transportation from plant 2 from the same exact reasons. Road transportation is more expensive and has lower emissions, and then ocean transportation is cheaper but has higher emissions, is more profitable. Once again, this is up to Hawkeye Chocolate to decide on which one you guys want to have, whether it's a lower cost or lower emissions. But in these two scenarios, you cannot have both.